Alright folks, in this video we're going to talk about flame straightening. We've covered some of the basic concepts in the distortion video on really why this works. But what we're going to do is we're going to look at flame straightening. This first clip is going to look at what we call line heats. And we'll look at other methods of straightening in later videos. I know I struggle to keep my videos short. I'm a detailed person, I like the details, and well, it is what it is. But this video I'm going to try to keep relatively brief by covering only one topic, and that is line straightening. We're going to look at two different parts. The first part is right here on the bench in front of us. What I have is I have a piece of 3/8 plate that was sheared. And shearing is like cutting something with scissors. Effectively, as we shear, one blade comes down through another part. The part is separated like paper is with scissors, and the process of those blades rolling causes the part to curve. And we can see that curvature here. The plate is bowed up. I'm using simply a scale or a level, can't even think, as a straight edge right now, and it definitely rocks. So we're going to attempt to straighten this out, or approximate it to be straight, by taking a couple of what we call line heats. So essentially, I'm going to set that off to the side. I'm going to take a scale and a soapstone, and I'm going to mark where I'm going to take my heat so I can keep better track of it. If I were to go through with this scale, the part actually appears to be relatively flat. And that's because the scale is short. It doesn't have a lot of length. But as we noted a minute ago with the level, which is 4 feet long, the same length as the part is approximately, we can see that opportunity to straighten this part out. So the first step is to find the high spots, and that's really what we're going to do. If I press lightly on the level and I begin to rock it, I can see where it moves back and forth, and in this case it's moving right here. Okay? I'm then going to go between that point and the other end, and I'm going to again look for another what I call high point. It looks like this is rocking. If I press real hard, approximately here, I'm just going to mark these with a soapstone, and then maybe even in between those two parts, it wants to rock right about there. If the part is uniformly curved, I should see a relatively uniform pattern of high spots down through. If this is the result of weld distortion, it's pretty easy typically to tell where you need to take a heat. It's opposite what the weld was, but this is just a sheared part. So I'm going to repeat the process on the other side. Again, noting that it's rocking approximately here. If I go between these 2 points, it's actually not that bad. It's a little bit of a crown right there. And then finally on the end, press down real hard and see where it wants to rock. It's about right there. So I have a pattern of high spots. I'm going to turn this up for the camera. Again, 1, 2, 3, 4, 5, 6. So I have 6 spots where I want to consider taking a heat, as I'll refer to it. Now I'm not going to hit all those spots at once. I'm going to basically go through and I'm going to hit these one at a time, and I'm going to see what the effect is. If I were to go through and take line heats on all of these spots, I could effectively roll it the other direction. Okay? If I had a press brake, I would put this in the press, and the press would come down, and with a V underneath, it would hit here. In fact, with this up in the air, I could actually push on this downward, and in theory, I could bend some of this out. I don't want to take one hit in the middle, because this wasn't knuckled, okay, to get the curvature. It is actually bent in a curve from the shearing action. So I want smaller marks, okay. Another alternative mechanically would be to put this through a set of rolls and unroll the curve to it. But again, most people don't have access to that. but even the smallest garages with the simplest welding setups have a torch. Now I've got a propylene torch with a large rosebud. It's not ideal for this, but it's not the worst thing in the world, and the acetylene torch will work fine. Basically what we need is something that will get the front side of the plate hotter than the back side, and that really is the key. So in order to keep this from turning into a twist, I'm going to make the heat square, okay? I could twist this, and we will twist later. I could twist this by taking the heats at angles, and it would actually roll this up perpendicular to that line and cause this part to be twisted. And sometimes that's what you're looking to do. But for right now, we're just going to cover the basics, and we're going to take these heats. So I'm going to mark all these spots, and then we're going to hit them kind of one at a time and see what the effect is. Now, the part will still be moving as long as it's hot, but the bulk of the movement will occur almost immediately. So I'm not going to necessarily let these cool 100% down to where I can put my hands in. In terms of heat forming or flame straightening practice, with line heats, we typically don't use water or any cooling mechanism. We do when we take a V heat, like when we bent the angle bar in a previous video. So I've got my 4 spots marked. Again, I'll just roll this up for the camera. What I'm going to do is I'm going to start off with the spot on this end, and I'm just going to try to casually unroll this. I'm going to take a really quick heat. I'm going to let the flame get right touching the material, the small blue part of the flame I want, right on the material, and I'm going to pull across relatively quickly. I'm not trying to get this to turn red, folks, okay? I just want to get the front side hotter than the back. Now, we know from earlier videos that when I heat this up, this will try to rise. And the reason it's rising is because the top side, which is getting hotter than the bottom side, is getting longer than the bottom side. So a pipe is round because the outside is longer than the inside, right? The physical diameter is longer. So as I initially heat this, I will see some rise. But this can't rise naturally because the cold steel, relatively speaking, on the bottom of the plate is preventing the natural expansion upwards. And the cold steel acts like a vise. It will allow some movement, but not free movement. But the shrinkage that occurs will be disproportionate because it wasn't allowed to expand in the first place. So we'll end up with a slight bulge. You won't feel it with a tiny heat like this, but the fact is it's there. Okay? And the effect is that the part will not go back to where it was. It will go further than it went in the first place because of that restriction to free expansion. So distortion always occurs when we have restriction to free expansion. So I'm going to go ahead and take the first heat, and then we're going to kind of check this as it cools. I might actually take a heat here and a heat here, looking kind of for the worst overall eye spots. But, you know, essentially I want to start to take a little bit of this out. That heat down there doesn't need to be very big. It's not out a lot. The bulk of the curvature is probably right here. So we'll see what we do. We're making this up as we go along. Good hot flame. I want the flame close, and I'm going to turn it quick. Better off, folks, to heat it twice than to heat it once and go too far. So I'd rather take a light heat and have to do it again than I can take a really large heat and find out I've knuckled it in the wrong direction. All right, I'm going to skip over and I'm going to hit this spot, which is the other bad spot. Do the same thing. I'm going to shut that torch off. Again, in order for this to work at all, we have to have a delta, a difference in temperature. So if this entire plate starts to get hot, then no matter how hot I get the top, it's not significantly hotter than the backside is. So we want to bounce around as we're doing this. Hopefully on the camera you could see as I took this heat, it rose up a little bit. I traveled slower, so I have some color change. I actually have a line here. I didn't see red at any particular time, but I've actually discolored the mill scale. The heat down here, I did discolor that minimally. All right, again, note soapstone, you know, it doesn't burn away, so we use soapstone to mark these for. So I'm going to check this really quickly with my rule. I don't want to warm this up significantly, but again, a real quick check. Right now, this sits almost perfectly flat. It's rocking only right over here. Okay, so I'm going to jump over there since it's physically away from the previous heats, and I'm going to take another real quick heat and see if we can't. Maybe we can get this without having to take all 6. 5 TV, folks. We'll shut that down. We'll not set it on the calculator. All right, again, I can't stress enough the importance to start with the heats light. Allow the material to stay relatively cool. This plate is obviously, been heated, but I can put my hand right on it here. I can put my hand on it in the middle lightly. Again, not bad. I don't want to get this entire part really hot because I need the difference in temperature to make this work. So right now I'm going to give it a quick check. We'll see how this looks. And then at this stage of the game we have to be patient. We have to exercise a little tactical patience and just simply wait. But with a quick glance, this is not rocking at all. I don't want to warm my level up because it's currently straight and I want to keep it that way. So we're going to walk away from this, we'll let it cool down, we'll come back in a few minutes. All right, while we're waiting for this plate to cool down, I thought we would take a look at this assembly right here. This is actually the assembly that we welded with a backstepping technique, although continuous welds, in a video on weld sequencing. As I mentioned in that video, the flange was actually kept pretty square, but the faceplate is actually warped. So you can see, hopefully in the camera, that we've got a crown here. I'm going to drop this back in the vise. And I'm going to take my scale and I will demonstrate. Again, that welding motion, that doesn't even make sense. The welding caused this distortion. As this weld on the bottom shrunk and it closed this way, it actually pulled the plate together. So essentially it pulled this plate down, at least from this perspective. Obviously this was upside down when it was welded, and it pulled this plate down. Now it also pulled the faceplate left and right, but because we welded left then right, then left then right, back and forth, that faceplate was, moved left and right, so the end result was it was square. But these were only pulled upward, so it was, pulled upward or downward again from this perspective, upward, and then a little over here, then a little over here, and the end result is that this is not flat at all. So we're going to attempt to straighten this, and again we're going to use only a line heat. Now ideally what we would do is we would come in and we would measure to where the edge of the weld is. The toe of the weld is what we're actually looking to hit. Now this torch is relatively large. It's not ideal for this situation. We would want more of a pinpoint heat, but I really think that this will work. It's not perfect setup. I don't really have flame straightening torches here at the shop, but we're going to do the best we can. So I'm going to put the scale in, and I'm going to measure essentially to the toe of the weld. And let me hop down here real quick and get a look. I've got weld spatter to deal with and things like that, but there we go. So the toe of the weld is approximately, right here, I gotta back this up just a whisker. The toe of the weld is approximately here, and I'm gonna put a little line down through the top. Okay, I'm gonna flip this over. We're about in the same spot. This was centered as best I could get it when I filmed this. So in an ideal situation, I would run a torch just on the outside of the toe of the weld here and just on the outside of the toe of the weld there. And what that's going to do is that's going to pull this up much in the same manner as the other plate moved down. The top side of the plate should get noticeably hotter than the bottom side of the plate, and of course the weld itself is holding that down under some tension right now, so it will not expand freely, and the net result is that since this can't grow on the top and bow down from the growth as much as it would like to, it's going to actually shrink more in the opposite direction. So we're going to take a quick heat. Again, blue flame, right on the part, nice quick round of heat. One side, I'm going to jump to the other side. I'm confident now that the center barrier will prevent the heat from scanning over. All right, thin parts can sometimes be a little more challenging to straighten than thick parts because, again, the heat transfer goes through the material so fast that it's hard to get the top significantly hotter than the bottom. In this case right here, we'll just do a quick check while it's hot. This is actually flat, okay? If anything, it's bowed a little bit in the other direction near the center. But again, to take a final check, we have to always allow the part to fully cool because stuff will move around as it goes. We will, of course, come back to that. What I'm going to do is I'm going to swing the camera around. We're going to take a look at this. This is cooled down completely, and we will see how it looks right now. All right, folks, so we're back. We're kind of bouncing between two projects here, but we're back to this plate. This plate has now cooled down. I can rest my hands on it. It's got a little bit of warmth. It's not completely cooled down, but you know, the table feels cold by comparison, but this is definitely not hot right now. Let's take our straight edge and see what we've got. At a quick glance, this is flat. If I press on the ends, back and forth, anywhere near the middle, here, this isn't rocking at all, okay? So a quick couple of line heats. In fact, we took 3, 1, 2, 3 right here. This you can see in the camera. Hopefully the first heat was light. This heat, there seemed to be a bigger rock in that area, so I took a little bit more, and then again, the same thing down here. The idea behind this process, again, is to go slow. I'm going to flip this over and check it from the back side. In theory, this could be bowl-shaped, right, and then it wouldn't rock. So we'll see what it looks like from the back side, okay? Again, back side, I have a slight movement. I'm not sure if it's the plate. Let me hold this down. I almost think it's the plate rocking on the bench. The bench is not flat. It's been welded and ground on 1,000 times. So let me lock that down. And I've got really no movement. Slight, if I balance this, it's like the tiniest little spot right there. Okay, so I could, if I really needed this to be perfectly straight, or at least, you know, straight as I can get with the straight edge, I could take a slight heat right here. But again, that movement is so tiny that I would want to make that heat really fast, okay? And in fact, for my purposes, I don't think it's necessary at all. In fact, I would go further. I would want this to be room temperature cold. I mean, this is cold by my the feel of my hand, even though the thermometer measures what do we got, 68 degrees all across the table. This is showing right now somewhere around 85 to 90, okay, in that range. Dead center, where it's probably the warmest, coming up on, say, shower temperature, 119, 120 degrees. Again, it's not too much for me to put my hands on. So I would want to let that cool completely down, right? But that is the basic process, and hopefully now you understand why it works. This is a really good thing to know how to do if you are buying material that has been sheared. A quick heat, and again, you got to be careful because you can go too far. You can knuckle this plate and actually have it rise up, much like we did with the angle bar. But you got to be really careful that you don't go too far. And again, if you have to hit it again, in general, let it cool completely down. Over here, we've got a different situation, and that is still hot. We're going to go take a look at that once it cools. All right, folks, I've given this a little bit of time to cool. Right now, it's still warm. It's running about 250, the highest, 130 at the lowest, depends on where I go. the movement has really stopped. As a general rule, you know, when you can put your hand on the part lightly, 120 to 130 degrees, good hot shower temperature, you're not going to get any more movement really, at least not measurable like this. With a micrometer or something, you probably could. But basically what I have now is this is dead flat on the end. It is still coming back slightly, I would imagine, as it cools. In the middle, I've got a tiny, tiny gap. It looks like I might have overheated it just a whisker in the center. And the other end, again, is dead flat. So it might be up 32nd of an inch maximum. But again, there's some guessing that goes along with this technique. The essence of flame straightening is really simple. When you're doing line heats, the torch acts like a machine coming down to press. So if you imagine a V-block and you have a part that's put in there and you press down in the center, the part will wing up. If I press here, the part will wing up. Essentially, the torch acts like the top part of the press and it will wing the part up. If you get the part excessively hot, where you're heating it red all the way through the thickness, it's not going to be effective because you need the front to be hotter than the back. So the trick is get the torch really, really hot, but travel quickly so that the top side really gets a lot warmer than the bottom. You're not going to see movement when you do it. You're not going to generally see color unless you've got something really thick where the top really is going to absorb a lot of heat. But as a general rule, start with a light heat, check it. If it doesn't go, travel a little bit slower. But keep that inner blue flame right down, kissing that part. You want it touching the part, and you will get the ability to undo distortion. Now we could use this technique to shape parts as well as we could to take shape out of them. And I've seen phenomenal work done with only torches and nothing else. No hydraulics, no pressure, nothing, okay? So again, part one of flame straightening, line heats. This is an introduction. Try it out yourself sometime. Close enough.